And Phil, I'm totally out of food, and there's going to be riots. But actually, I think we have about what do we have? About 15 of us, something like that. Typical. And
Okay.
I'm not sure how familiar they are with ActiveState, but certainly interested in technology and don't hold back on going deeper.
Okay.
And is there a way for me to make this full screen? Who knows Skype better than I do? Oh, this one. There you go. So Phil, we're full screen on you, and if you need to
Okay.
switch sides, and I think what we'll do is, if anyone has questions, do you want us to wait? How would you like us to do it?
Um, yeah, so I'm going to talk about Cloud Foundry and Stackato, but I have no idea um, how much anyone knows about Cloud Foundry. And so obviously if I can't see you guys, so it's going to be hard to gauge if anyone's completely confused or I'm going too deep or too shallow. So yeah, I
Well,
mean, if you could give me some feedback, like shout out any
okay.
questions anytime is definitely good.
I used it when it very first came out from Pivotal or Spring or some whatever company it was at the time.
Okay.
So what's the history there?
Yeah, so a little history too. Can you hear everything okay?
Yeah.
Okay.
So
How's
somebody used it when it first came out. It was Spring or something. So yeah, Cloud Foundry. So yeah, I'll just get into the slides. Just so you're going to lose my face, unfortunately. Sorry about that. Okay. So can you see
Yep,
my screen? Okay.
yep, perfect. And I don't think we'll be shy about questions, right? No, this group is usually not shy.
Okay, great. Okay, so yeah, I'm going to be talking about Cloud Foundry. Yeah, I'm Phil Whelan, currently software architect at ActiveState, working on Stackato, which is based on Cloud Foundry. I've been working on the Stackato project for just over 3 years as a developer and a technology evangelist, and now I'm software architect. Um, so yeah, ActiveState is a company up in Vancouver, Canada, and we've been here from about '97. A lot of people know us from things like ActivePerl, ActivePython, and Komodo IDE. So we have a long history, and we've been working on platform as a service and Stackato for about 5 years, I think. So yeah, Cloud Foundry, for those who don't know, the current definition is a platform for cloud native applications. So what that means is applications built to run on the cloud. And generally that follows something that was defined by Heroku, which is 12-factor applications. So I can go into a bit more of that if you like. Generally, it's an application that doesn't really have any state, can scale horizontally, isn't really aware of the platform it's running in, so it's kind of platform agnostic. It writes all its logs to standard error, standard out, and things like that. So as we've been making Stackato, we keep that in mind and guide customers in that direction, but also a lot of customers want to run legacy applications on Cloud Foundry or Stackato. So we're trying to support that as well in various ways. So for instance, the logging, allowing customers to still write their logs to disk, and then we pick them up and pump them into the system. So obviously that's not the greatest definition of Cloud Foundry. Does anyone want more of an explanation of what Cloud Foundry is?
We good with that? I mean, it's platform as a service, right? Is that term going away now?
Yeah, the Cloud Foundry has traditionally been platform as a service, or PaaS for short. A lot of people don't like that term, and like the AAS has been used for many things, and it's getting a tad annoying. The current spiel about Cloud Foundry is that platform as a service is a feature of Cloud Foundry, but Cloud Foundry isn't entirely platform as a service. So, and I'll cover that, what I mean by that, a little bit in a couple of slides' time.
Okay.
So generally, the idea behind platform as a service, for people who don't know, is developers can just care about their code, push their code to the platform as a service, and not really care about provisioning databases, installing system dependencies. Just really focus on their code and then tell the platform, hey, I need a Redis database for this, maybe a Memcached or Postgres database or a RabbitMQ message server. And the platform will provision those things and then wire them together. So this is a really old slide. This is from early version of Stackato, but from one of our first customers. So they were a very large Fortune 200 company. And so they kind of jumped on Stackato. They're very interested, and they got lots of people using it. And then they sent us this slide because they were quite excited about how many more languages they were now using. So before they were using pretty much 100% Java, and then after they've been using platform as a service for a while, the developers were using different languages. So, I mean, there's a lot of JVM languages in there, but you can see the big kind of pinkish orange on the bottom right. That's Node.js, and then there's some Perl in there. PHP is another, almost a quarter of the graph. So people were using a lot of different things. And that's one of the benefits of platform as a service, Cloud Foundry or Stackato, is it's what we call polyglot, so you can program in many languages, because the platform is agnostic to what language you choose. Okay, so I'll give you a little bit of history on Cloud Foundry. So Cloud Foundry started in 2011 in April. It actually goes back a little bit further, but people disagree on whether that history is accurate. There was something built based on a project called Cloud Tools that started in 2008 that was called Cloud Foundry. It lived on cloudfoundry.com, had many of the features of platform as a service. That was acquired by SpringSource, and then VMware acquired SpringSource. And then a while later, the Cloud Foundry as we know it was announced as an open source project by VMware, which shared the name and the domain name, and was coming out of VMware where the original project was. But yeah, I've been told they're two separate projects, and I should never talk about the original one, so I didn't mention that. So yeah, officially it all started in 2011. At the time, ActiveState were already looking at building a platform as a service. We already started development on a platform as a service. A lot of our business is in enterprise versions of dynamic languages, so Active Perl, Active Python, Active Tickle is another one. And a lot of our customers were seeing things like Heroku that was focused at the time on just deploying Ruby. And Ruby and Perl and Python are quite similar, so our customers were kind of asking, like, how can we do this kind of thing with Perl and Python? So ActiveState saw an opportunity and started working on it, and then VMware announced the Cloud Foundry open source project. So initially there was a bit of dismay, but I think by the end of the day of the announcement, ActiveState had decided to build on Cloud Foundry instead. So we pretty much jumped on it from day one. Cloud Foundry was written in, it was all written in Ruby to begin with. The cloud controller, which is a key part of Cloud Foundry and it provides the API and the kind of brains of the system, was a Ruby on Rails application. And then the other components were also Ruby applications. So to begin with, it supported Java Spring and Ruby and Node.js applications. And ActiveState submitted the Python support and also Perl support of the early version of Cloud Foundry. So yeah, the first version of Cloud Foundry was Cloud Foundry version 1, although it wasn't called version 1 until we had version 2. But yeah, it was a CFV1, you might hear it referred to sometimes. And that's what ActiveState picked up. And then February of the next year, we actually released our first version of Stackato. And so yeah, started selling it to enterprise straight away. The next year, the project moved from VMware and was spun out into Pivotal. Pivotal is a very agile. Pivotal Labs is known as being a very agile company. They got some investment from GE, and they took on the project and kind of built a lot of it from scratch. So that's during 2003. We basically got Cloud Foundry version 2. And Cloud Foundry version 2 was still in Ruby, but it was a lot better code base. Things like the API of the cloud controller were proper RESTful interface. And so yeah, it just got a good upgrade there. And then that was called Cloud Foundry version 2. So currently what we have is Cloud Foundry version 2. And now kind of in the works, there's some experimental v3 APIs. So at the end of 2003, we released Stackato 3.0. And so that was based on the Cloud Foundry version 2. And we also used Docker at that point, because that had come out earlier that year as well. So it's quite an interesting year. And then if we jump forward to 2015, quite a lot has changed from when the Cloud Foundry project started just a few years ago. Now there's a Cloud Foundry Foundation, and there's a long list of organizations as part of that foundation. There's lots of components of Cloud Foundry now that are distinct and have teams working on them, and a lot of new features like logging. The services APIs, so services are kind of broken out into external brokers that people can build and deploy separately. There's Bosch, which is a way to manage a cluster of the open source project. There's a new project called Diego, which is a kind of rewrite of probably about 50% of Cloud Foundry, and kind of trying to separate Cloud Foundry into distinct areas. So Cloud Foundry has kind of been, all the components have kind of worked very closely together, and now we're trying to decouple that more into kind of the higher level things that deal with users and applications, and the lower level things such as managing processes, which is what Diego focuses on. And Diego has a lot of overlap with things like Apache Mesos and Google Kubernetes, if you've heard of those. Build packs are a big part of Cloud Foundry. They're basically the recipes that build up everything from the user's code and the base Linux container up into the running application instance that can then be scaled out across the cluster. And they came in Cloud Foundry version 2 as well. But there's a lot of focus on build packs. And if you're familiar with Heroku, you might be familiar with build packs there, because Heroku created the concept of build packs and made them very popular. And we've got a Cloud Foundry Summit coming up in a couple of weeks in Santa Clara. So if anyone's in the area, then you should definitely come to the summit if you're interested in Cloud Foundry, because it'll just be all talking about Cloud Foundry. And then once a month we have what we call CAB calls, which is the Cloud Foundry Advisory Board meeting. So those happen once a month, and I generally listen to them and write everything that happened. So if you're interested in what happens on those, you can go to ActiveState's blog and read up what's happening, latest developments in Cloud Foundry. Okay, so before I go on, is there any questions? I know I'm hammering a lot of information, but
yeah, what happened to Engine Yard and AppFog? They were kind of early on, big at the beginning. Are they gone, or are they still around?
yeah, so Engine Yard, I think it's kind of reinvented itself a little bit in kind of being more of, I mean, I'm not too clear on what Engine Yard is doing. So Engine Yard is still going, but I'm not really sure what direction it's going. I know they had some bits and pieces to take, like an Amazon, give it your Amazon login, and you could build up some kind of cluster, so you could do your own kind of private infrastructure, but don't really hear too much about that. AppFog, I was speaking to one of the developers of AppFog version 2 last week. So AppFog was acquired by CenturyLink, and so they're actually getting ready to have a release of kind of their version 2. So they've been working on the wraps for a while, and that's going to be integrated into CenturyLink's public cloud infrastructure. So CenturyLink has a lot of offerings very similar to Amazon Web Services, but obviously not as many people know about that. And then AppFog is going to be their platform as a service piece on that.
Okay. Anyone else have questions? No, I think we're good.
Okay. So yeah, so the Cloud Foundry architecture. So currently the Cloud Foundry architecture kind of looks, it's kind of got 3 pieces. So there's the stateless part, and that's, we call that the runtime. And that basically means it's the application. So when you build an application to run on Cloud Foundry, you're basically building an ephemeral application that can be scaled up. It doesn't matter if it goes away, you just start up another one. So it can be scaled up, scaled down. If you load balance across these instances, if I log in on one, then I shouldn't be logged out on the other one. So you move all your state out of the runtime application, and you move it all across to stateful services. So Cloud Foundry has a well-defined API for creating service brokers, and in Cloud Foundry version 2, it's actually designed so that the services never need to talk to Cloud Foundry themselves. They just expose an API, and Cloud Foundry can talk to them, provision services for users, and bind those services to applications. So you could have a service up in the cloud, maybe on HP Cloud or something, and it could expose the RESTful interface, and a Cloud Foundry administrator could say, I want to bind this service and make this service available to my users, and then the users who are developers can come along and say, I want to provision a MySQL database, and then the Cloud Foundry platform would talk to the service, ask for a database, it would return the database instance, and then that database could be bound to any application that's in the same scope. So it could be, if that developer's in a team, then maybe all the applications in that team could share the same database. So that's essentially what services are. And then there's a third part, which is platform operations. So that's Bosch. That's a newer piece that's been growing in popularity. And so Bosch works as a kind of orchestrator of the platform itself. So it can build Cloud Foundry, it can scale up the cluster, it can upgrade a cluster. This is a piece that Stackato at ActiveState we don't use with Stackato. We have our own deployment mechanism, so I'll talk about that in a minute. Is there any questions on this?
We're good?
Okay. So going a little bit lower in the architecture, This is the key components of Cloud Foundry. So very similar to a lot of cloud architectures. So you basically, requests come in, you have a router which routes the requests to the right places. The request could be going to a login server for the platform, or it could be going to application instances. So the router handles requests for everything on the platform. There's an authentication server. So there's UAA and login server. They kind of go together, and they've actually been combined in the Cloud Foundry open source project as one service now. Below that, you have the cloud controller, which is the API of the system and also kind of the brains of the system. As Cloud Foundry is evolving, some of its responsibilities are being moved out of the cloud controller, because cloud controller is historically very heavyweight component of the architecture. And sitting next to that in the diagram is the health manager. So the health manager monitors the state of all the application instances. So if I'm a developer and I push my application and I say I want 5 instances of this running across the cluster, the health manager will keep track of those instances. If one of my instances dies for any reason, maybe I just wrote it badly and it's got a bug in it, the health manager will make sure that new instances always come up, and it will do that by talking to the cloud controller. The cloud controller will then choose a DEA, which is the component underneath it. It will speak to a DEA and say, can you provision an instance of this application? The DEA will then talk to the blob store, get the instance of that application, and run it within a Warden container. So where you see Warden here, in Stackato, we actually have Docker. Was there a question there? Or maybe...
I just think blob storage, is that really the name? The blob store? I mean, that's not a lot of effort in that name.
I didn't name it, so.
That router component, curious, is that like a dynamic component that you can create or manipulate at will?
Sorry,
He asked about the router. Is that something dynamic?
Yeah, so the router is dynamic. So the way the router works is it will listen on the message bus, so you can see NATs near to the bottom. All the components listen on the message bus, and when a component comes up, it will make an announcement that I'm up, and it will make a special announcement to the router to say any requests for, so for the cloud controller, it'll be API dot and then domain name. So any request for this, please send to me. So, and it will give it its IP and ports. And so when applications come up, the DEA will tell the router where the applications are and where to route those requests. Same as the cloud controller, when the cloud controller comes up, it will say route request to me. Same as the login server. So all the components can come up and have requests routed to them through the router.
Does that answer?
And also when components go away, they say, if they shut down gracefully, they'll say, oh, I'm going away, you can stop sending requests for me. And so if you've got multiple cloud controllers in the system, for redundancy, then if they shut down gracefully, they can unregister themselves instantly, which is quite handy. And then if they go away ungracefully, then there's a timeout mechanism where they'll be removed from the routing table. Okay, so I think this diagram mainly comes from, I'm getting some feedback there, from CFV1, where service brokers were a core component. Service brokers are moving more to the outside of Cloud Foundry and more as an API that you implement. And then at the very bottom, we have log aggregation and metrics. So there's a distributed logging system. So all the logs of all the applications are all funneled into a central place where then they can all be streamed either to the end user on their terminal So if I'm an application developer, I've deployed an application and I've scaled it up to 10 instances that are spread across the cluster. I can have all those logs streamed in real time to me. And a newer part of that is the metrics, which kind of goes hand in hand with the logging. So metrics are being added slowly to the components so that administrators or application developers can get metrics. So routing metrics, for instance, how long a request took, latency, etc. Okay, so I'll move on. So this is a diagram of Stackato. I won't go too much into detail on this, but it's basically taking those components that you've seen and then laying them out. And then this is something we use to demonstrate how Stackato is different or the same. So some things are different because we added them to fill a need. Some things are different because of the way we deploy Stackato, so we wanted a smaller footprint, so we wrote our own implementation. Some things are different. For instance, we have a log yard down at the bottom there, and Cloud Foundry has Logaggregator, the two logging systems. They're very similar, but we just built log yard before. We have Docker instead of Warden. And a question we often get asked is like, why did we switch from Warden to Docker? But we never actually used Warden because we were using LXC containers before Cloud Foundry was using Linux containers. So, and there's a couple of things we still kind of have that on in upstream that we have tried to open source, but it's a little bit too coupled to Stackato to be useful to anyone else. One of those is the persistent file system. So that's basically useful if you're deploying things like WordPress. So if you deploy WordPress, it generally assumes that it's got the local disk to upload and store images on. If you went to a different instance of that same application, the local disk wouldn't have that image and will return a 404. So we provide a file system service that basically gets bound to every application instance, so you can have a local disk that's shared amongst the instances. And it's provisioned in the same way as other services. And then there's...
Oh, I'm sorry, I have a question for you.
Yeah, sure.
So if you have a cluster, is Stackato sitting on all the different servers and there's pieces of it, or is it just sitting on specific servers?
Yeah, so Stackato, I've got another slide that I'll just show you in a minute, but yeah, Stackato is shipped as a virtual appliance, and that virtual appliance has everything on. So every node of Stackato has exactly the same things on it, and we wire a bunch of Stackato nodes together, and then you can turn on and off particular roles. So everything you see in this diagram will come on the virtual appliance, but on some you want to turn on the DA role, and others you want to turn on the cloud controller role. So you can turn them on and off. So you can do all that through the web console as well, which is pretty handy.
Okay.
So the other service here is a port service, which is in Cloud Foundry, which is basically a way to provision TCP and UDP ports. So some applications require more than just a HTTP port to serve web requests. So if you have any port you want to use, then you can provision this as a regular service and bind it to an application, and that application will then get that port. Okay. And then AOK, you can see there is, that's our implementation of the UAA authentication. So UAA is the authentication in Cloud Foundry, and it's a Java Spring application, and comes with a Java Spring application, the login server. And since we ship as a virtual appliance that we want developers to download and be able to run on their laptop, just as easily as you could upload it to Amazon or HP Cloud and build up a large cluster, then yeah, the footprint of that was just too big, so we basically took the test suite and built our own API compatible version of that, with some other features that we needed to support some of our customers. So this, I always find this blue doesn't display very well on a projector. So you can see a box that takes up most of the screen. It's got a light blue background. So that is basically the virtual appliance we ship with everything in. Sorry, was there a question?
No, we're good.
Okay. I think I occasionally get some feedback. It sounds like someone's asking. Yeah, so we build the virtual appliance to deploy on any hypervisor or infrastructure as a service. So we build an image for VMware or Amazon Web Services or OpenStack, HP Cloud, KVM. And so it's the same version of Stackato wherever you go, and you can wire those instances of Stackato together. So it kind of means that if someone's thinking of moving from VMware to OpenStack, they can build a cluster and effectively migrate it across. Or you could do something crazy like wiring your laptop to a cluster on Amazon AWS, because every instance of Stackato is the same. And so some of the things on the right side here are, so yeah, as I mentioned before, you can stream all the logs. So one thing that Stackato supports, which isn't in the open source, is system logs. So all the logs of all the Stackato components can all be streamed by an administrator into Splunk, as well as application logs. A lot of our customers already have large high availability databases and teams that support those. So they kind of want to keep using those. And so we just provide the glue to kind of provision onto those. So for instance, if a developer was using Stackato on their laptop, they could say, I need a MySQL database. It would provision a MySQL database on the Stackato machine on their laptop. But if they then pushed out to the production or the development cluster that was wired into a larger managed database, then it would provision the database on there. And so the developer, there's no difference, but under the hood, it's using those. So is there anything else I can say on this? Any questions on this diagram? There's a lot of stuff going on here.
He asked if you support like packet analyzers like NetFlow.
No. So that would be kind of at the routing layer, I guess. Is that right?
Yeah.
Yeah. No, so there's no way to plug anything in at the routing layer currently. So everything currently that is in control of the developer resides inside the Linux container. So I mean, we let you kind of do anything you want inside the Linux container. So you can use the build packs to deploy the Linux container, or you can run pre-running, post-running, pre-staging hooks. So at any point in the life cycle of the Linux container, you can actually get in there and run bash commands or run scripts or compile code, or can kind of do anything you want inside that Linux container. So if you can install it in a Linux container, run it in a Linux container, then you can do that. But yeah, on the administration side of the routing, we don't currently have anything there. Coming down from some upstream developments that's currently in discussion is a routing API, which would be a way to inject some processes into the routing workflow. So you could essentially deploy an application and have things routed through that application on the way to your primary application, which is kind of interesting. So yeah, also in upstream Cloud Foundry, in the open source projects, we should say, there's a lot of metrics coming out. So when you have a request going through the router, it will actually fire off events of when that request started, when that request ended, and as many events as you can, so you can determine latency and everything from that. So that would be quite useful. Yeah, this is just a big long list of things we've added, changed, etc. Yeah, so we're currently on 3.4. So yeah, and as I mentioned before, the big thing in our version 3 was Cloud Foundry version 2 and Docker, and everything went to Heroku build packs, which was a big change. One important thing from a kind of ops perspective was like the zones. So availability zones kind of allow you to have different zones. So if you're on like HP Cloud or Amazon Web Service, you have the concept of zones. So they're on separate networks, separate power supplies. So if one goes down, then you don't lose the whole application. So Stackato will actually make sure that the instances of the application are distributed evenly across there. And then the placement zones are a kind of way to say these are developer applications, these are production applications, or these are slow disks, these are fast disks, any way that people want to cut applications up. Common one might be these are really important applications. We don't want anyone running test applications on the same machines as these. So yeah, that's pretty important for enterprise customers, we found. And then we have activity stream. So it's kind of like some social features, so you can actually see what's going on, and then you can comment on those things. And auto scaling, I can show you that. And versioning. What else? Yeah, so I'll show some of these in a demo in a moment. So sorry, Stephen, I forgot to ask how long we have for this my talk.
You're good. No one's
I'm good?
run out yet.
Okay.
You're doing good.
All right, good. That's good to hear. So yeah, ships as a virtual appliance, I've mentioned that. We have an administration tool on Stackato called Cato, which I'll give you a quick demo of. And basically this is everything you can administer through Stackato, it all goes through Cato. So that's something that's specific to Stackato, which isn't in Cloud Foundry. Cloud Foundry is everything is done by Bosch, and things are pushed out to the cluster. We do more, everything is on every machine and then configure it after. So a slightly different mechanism there. And we manage all our processes by supervised D, and what that means is that Cato, or our cloud controller, or web console, which is how people will access it, it can talk to every process on the cluster and manage all the processes on the cluster, which is kind of handy. And then we have a centralized configuration. So if you're using open source Cloud Foundry, then you generally make changes in the configuration manifest, and then you kind of render those changes and push them out to the cluster and restart processes. We've used a slightly different approach in having a kind of central store of the configuration. So if you've got 100 DEAs, we can make the change through the web console or through our Cato command line tool, and that instantly goes out to all the applications, all the Stackato processes. So a simple example of that would be, say I wanted to change the logging level of the DEA processes. I could change that, and Stackato processes actually watch the configuration, so they can make real-time changes without necessarily restarting the process. So it makes it a lot more dynamic in managing the cluster. Yeah, I mentioned already the UAA. Probably don't remember what UAA is, but we got a different one called AOK. The Go router, yeah, we've got a different version of the router, which is written in Node.js. Originally, Cloud Foundry had a router written in Ruby, which we thought wasn't the best choice for a router. So we wrote it in Node.js, and since then, in the open source, there's a Go version called Go router. So these are pretty much feature compatible at the moment. And then similar story with the login system, as I mentioned. And then, yeah, we use Docker, not Warden. The reason for that was we were using Linux containers, and when Docker came out, the implementation of actually provisioning the containers was well implemented, and it had a lot of eyeballs on it. And so Docker's kind of under the hood so far, just for provisioning those base containers that we then build up. And with Cloud Foundry end users, so developers pushing their applications, we use the CF client. So the CF client, you can push your code to Cloud Foundry, you can log in, you can target different instances of Cloud Foundry, you can get the logs, you can restart your application, you can scale up your application. So all the things you can do to your application, you can do through the CF command line client. With Stackato, we've always had the Stackato client because we built a lot of extensions, so we've implemented those, but the clients are pretty similar. File system service, port service I've already mentioned. Okay, this is my demo slide. So is there any questions before I get into the demo?
No, we're good. We're ready to see it.
Okay. So, so if you download Stackato off ActiveState.com website, you can fire it up in VirtualBox or VMware and start using it straight away. So you're generally given a URL that you can then go to your browser and connect to. It gives you a first user setup. So you'll enter your username, password, and then you'll be able to start pushing applications straight away. So for instance, you can go to the App Store here, and the App Store is just for demo purposes mostly. So we've got lots of applications written in lots of different languages, and they use different back-end databases. And so all of these applications, you can click on the README. You can go to GitHub, download those applications, tweak the applications, and push them to Stackato yourself. So I'm going to push this one. So this is a Python application. It uses a Redis database. It's a basic currency converter. So generally, what we need to do with these applications is add a config file. So that config file, I don't know if you can see. So give me a shout if my screen is too small anytime. So
We can see it.
okay, great. So yeah, this application needs 128 megs of RAM. So it's using a service. This service we're going to call bottle currency-db, and that's going to be a Redis database. So if I go back to my application here, and I click on deploy. So what's going to happen here is it's going to pull it down from GitHub, and then it's going to push this application, basically all the files that you see on the GitHub repo, or push them into Stackato. Stackato is going to pick up this manifest file. It'll provision a Redis database because we don't currently have one under this user of this name. It provisions a Docker container. It'll put your application code in that Docker container. It'll then use a build pack to build up that container for the right language. And then when that application is ready to go, it will persist that away into the droplet store. Sorry. Let me try this again. I'm actually going to do this on a different cluster because I'm not sure what state my VM was in, because I think I might have been using it for development earlier. Okay, so I'll do exactly the same thing, but this one is actually on, it's a cluster on HP Cloud. So if we go to the cluster, you can see we've got 5 nodes. It's a DEA, 2 DEAs, so there's 2 machines where my instance will be. So exactly the same. So I've got to choose a space. So I choose the development space. I can choose a different domain. It's just one domain I can assign my application to. We've got a few different placement zones here. So I deploy my application, and it works seamlessly. So yeah, again, it's pulling it down from the same GitHub, building the ephemeral application inside a Docker container, and then it persists it away in its ready to run state. It's provisioned a Redis database, and then it brings it up in another Docker container, wires it all together, and also assigns the DNS. So we can open it here, and you can see it's at this URL. If anyone can read that and type it in very fast, you could actually go to this application and try it yourself, because it's running up on HP Cloud in the public. So yeah, it provisions this subdomain for the application, and we can change that if we want. So it's storing all the currencies in a Redis database. We can see all the logs here. So as I was making requests to the application here, you can see all the logs coming out from this instance. So we can see my instances here. I've got one running instance. If I scale that up to 2 running instances, you'll be able to see a second one coming up, and it's already running. So now when I refresh this page, you probably can't see me refreshing, but it's load balancing between the 2 instances there. And it does a kind of round robin there. So I can scale that up to 4 instances. It'll bring up another 2. And so you can see it's distributed across those 2 host machines evenly. And so I've got 4 instances running now. They come up very quick because they're already ready to run. And then I can scale that back down to 1. I can also use the auto-scaling feature. So I can, depending on the CPU threshold, I can say I want at least 1 of these running, or maybe I want at least 2 of these running, but no more than 7. And so it's going to bring up the second one there, make sure I got the minimum, and then if all the hundreds of people at the Boise Meetup are hitting this URL, then we'll see the load go up, and then more instances will pop up. And again, I can see all the requests coming in from that application. So if there's any questions on that, shout out. But otherwise, I'm going to delete that application and then show you the same thing from the command line. So apologies if I hang up. I'm trying to move the Skype little buttons out of the way, and they keep ending up next to buttons. So yeah, if we go back to the App Store, I can find this application by following the README, or you can say clone repo. So I've actually cloned the application already down here. So yeah, shout out again if you can't see the text for any reason.
We have it blown up pretty good.
Okay, so yeah, so you'll target the Stackato cluster you want. This is the one on HP Cloud, so I'm going to target that one. And then the general workflow is you then need to log in, but I'm already logged in. But if I was to log in, I would log in like this. I'm sure you've all seen a login before. So yeah, this cluster is using a 20 gig free license, so anyone can fire up a cluster similar to this for free in production or wherever they want, for as long as they want. You just need to go to the ActiveState website and get a free license. So I'm going to push this application to Stackato, and this is the dash n basically means no problems. So thanks for a better demo. So yeah, it's going through all the same steps again. Maybe you can see the logging a little bit better now. So the way build packs work is I can either specify a specific build pack that I want to use, or I can have Stackato run through the build packs that are installed on the system and choose the best one. So it can detect certain things about the application and decide that it's a certain type of application and use a certain type of build pack. So this one's already running. We do Stackato open there. It'll pop up my browser. Okay, so we can see here. So I'm going to tweak this application a little bit. So I'm going to change the color to red. I'm going to push the application again.
The speed that it builds and everything, is this pretty standard, or is it pretty fast because it's a small app?
Yeah, I mean, it depends on the application. I mean, Java applications are a lot heavier and take a lot longer to build. Sometimes it depends on how long it takes to download, like we call the assets. So now I've just updated that.
So does it still rebuild and push everything, even if you just change one file?
Yes, it'll go through the whole build process. But so one thing that we've done with Stackato is make it into a zero downtime switchover. So it basically brings up new instances before the old one goes down and phases over quickly to the new one. So if you're refreshing the page, you won't see downtime. Cloud Foundry open source doesn't yet support that, so there's more of it's more on the client side to do blue-green switchover, and you basically do that under the hood. Cloud Foundry does that by deploying two applications with the same URL, and Cloud Foundry will equally balance those, and then removing the URL from the one app. Whereas we do it more at the container and routing layer internally. Sorry, you're asking me a question about how long it takes to deploy. So yeah, generally the time it takes is on downloading the assets. So the asset might be the Java 8 runtime.
Okay.
One of the innovations that Cloud Foundry has done with build packs is actually create the concept of offline build packs, which they're now calling cached build packs. And what that is all of the assets that the build pack would install are all bundled with the build pack. And a cluster administrator can download one of these build packs that has all the assets and install it. The problem with that is that Cloud Foundry now is, I think, 47 gigs, which is pretty big, and like 90% of that is build packs. So because we ship as a virtual appliance, we don't ship with cached build packs, but you can install cached build packs and have all the assets sitting on the machine there.
Open source by committee, just look at OpenStack, is not good. So I would just point out that about a year and a half ago, almost 2 years ago when I first came to HP, and I was working on just their public cloud, I actually went out there myself and wrote a series of blogs on using the Stackato stuff. It was almost 2 years ago. And it's really that easy. I mean, he showed it, and it's like, well, that was easy. And I can tell you, even for me, who hadn't written code in 15 years, it was that easy. It's really cool. And again, just go to ActiveState to get it, right?
Yeah, so, yeah, I mean, basically, I've seen some customers where they've never done any Node.js before, and they've gone to a conference and they've and basically grab like a couple of lines of Node.js that do a very simple proxy between two legacy systems and push like that one file, because you don't need a manifest file or anything, because Stackato for the most part can detect what kind of application it is, and then push that and then scale it up, and these few lines of code are, you know, powering the glue between two big legacy systems. So one more thing I wanted to show you. Is everyone's eyes glazing over here on the demo, or I can keep going all night?
Oh, we got a question.
So the build packs for dependencies is what I'm thinking you're using. How is it finding out what the dependencies are specifically?
Did you hear that question? You need me to repeat it?
So how's the build packs finding out what the dependencies are?
Correct.
So, I mean, a lot of it is on heuristics. I don't know the details of all the build packs. A build pack will basically elect itself to say, yeah, I'm going to take care of this application running what's called a detect script. So a build pack has 3 scripts. The first is detect, and the second one is compile. So detect scripts, all build packs, all their detect scripts are running in order. So an administrator can say, I want the Java detect script to run first, and then the Python one, and then something else. And so if that detect script passes, that build pack will be chosen to be the one that builds the application instance. And then the next thing that runs is the compile script that's in the build pack. And that compile script can be anything. It can be a bash script, it can be a Ruby application. So anything that you can run can be in that bin compile. So not every build pack is built the same, and that's actually one of the downsides of build packs is there's very little structure around how you should build packs. Cloud Foundry is trying to build some structure around that, but generally the way they work is they go through a series of looking at the code and seeing what kind of application it is. So the Java build pack, the Cloud Foundry Java build pack is actually very big and tries to cover every kind of Java application you would ever push, and runs through a very long and complex Ruby application to figure that out. But yeah, I mean, you can quite easily build your own build packs, and some people don't like the Java build pack because it's too big and they're only deploying a certain type of application, so you can just create a simple build pack that's just going to run a simple recipe to build your type of application if your enterprise is using a particular application. And then if you want to go deeper down the stack, with Stackato, you can provide your own base Docker image. So we provide a base Docker image that builds any application on top of. But if you've got an organization where it's like, well, we always deploy Java applications, so we might as well just bake it into the base image, you can also do that as well.
So you said you give, what, 20 gig free or something? Is that running on Amazon or your own hardware, or what?
Yeah.
What's your home out with it?
Yeah, so I mean, we're just giving the software. So it's bring your own infrastructure. So you can carve up that 20 gigs as however you like. So you can put that on one huge instance, or generally we recommend like 5 instances of like 4 gigs each. That works out pretty well because you can get the right kind of setup of a few DA instances to distribute the instances across, and a router or 2 routers if you want, and cloud controller. But yeah, it's just Stackato doesn't really, for the most part, doesn't know what infrastructure it's running on, and all it will do is check you've got a license and check how much RAM you're using, and that's it. So yeah.
So then beyond the 20 gigs, whatever it is, then you guys bill per gig you're using?
Yeah, so beyond 20 gigs, that's kind of how we keep the lights on. So You'd need to talk to our sales team after that. Yeah, so I was going to show you like rolling back the application. So this application I pushed and changed the background to red. You can actually, we keep a history of the application, so you can go in and you can roll back the application to a previous version, and then it phases over to the new application. So you can do that, or you can roll back again. So for people who don't like red, that's pretty handy. And then on the administration side, so we can go in and look at the administration. So actually, before I do that, you can actually SSH into the Linux containers, or the Docker containers, however you like to call them. So anyone who pushes an application can get into those containers, and so now I'm in the Docker container where my application is running. You can see my Python application running there. You can see all the things in my application. So you could tweak this. This is helpful for debugging or trying to figure out why your application won't come up or something like that. And so a common workflow if you really having problems is you can deploy where you have like a null build pack that would basically deploy nothing to an application, and then you'll have an application which is basically a long sleep that is the application running. So and then you can as an administrator, you can get onto the system, and you can configure the whole system through this. So all the configuration of the whole cluster is in here. So if I had 1,000 DEA nodes, I could change things. I'd probably be a little bit more careful if I had 1,000 nodes, but so I could change the debug logging level. Actually, that's get. But yeah, you can do that, or we've got logging, so you can see the logging. This is the system logs of the whole system. So if something's going on, you can kind of see what's happening there. So for instance, if I was to restart this application, you'd see a lot of activity from different processes around Stackato. So you can also do dive in of specific components if you just want to log those. So you can see the DEA is where the instance has been created, so you can see what's going on with that. So yeah, there's a lot of stuff going on in Cato. You can upgrade the system to a new version of Stackato. You can set your licensing. You can attach nodes. So generally we do Cato node attach. You attach a new node to the cluster. So Stackato actually, if you're on infrastructure as a service such as OpenStack, such as HP Cloud, or you're on Amazon Web Services, or CloudStack, you can have Stackato monitor the memory usage of the cluster, and then actually scale itself depending on how much memory it's using. So if I kept pushing apps all day, or I had auto scaling turned on, I can actually have Stackato talk to the infrastructure layer and say, fire up another instance of Stackato, and that instance will come up and wire itself into the cluster. And the cluster would keep growing, and your bills would go up and up. So yeah, you can see all the memory usage of on some real-time stats here. If you refresh it, it gives you the requests coming through. And this whole web console is it's a JavaScript web console, so it's 100% running in my browser. So anything you can do in this web console, you can do as over API calls. So you can kind of script everything in Stackato. And most of that is the Cloud Foundry APIs as well. So we've just extended the APIs in a lot of ways. Some other things you can do, you can turn on SSO. So if I were to turn on SSO, then no one can access this application unless they're logged into Stackato. So we need to restart this application. So if I open this application, obviously I'm logged into Stackato in this browser, but if I were to open it in an incognito window, I don't have the correct SSL certificate set up here, so the browser's warning me, but it's coming up that I need to log into this application. So then I need to log in with and then I don't have the correct SSL certificates for this application either, so, and then I get into the application, and then the application will actually receive a couple of extra headers to tell it who I am. So if you wanted to build something with a little bit richer interface that keeps track of who's using it and who's logged in, or a social network site, you could do that on top of this as well. Okay. Timeline basically gives you everything that's happened to this application. So you can see where it started, deployed a new application. I rolled back to version 1 earlier. I stopped the application. I could comment on this. And then you start a dialogue on that if you wanted. So we tried to build in some social things. Environment variables are a kind of key part of cloud native applications. So the runtime or the applications are generally ephemeral and they don't know anything about the environment they're running. So everything that you want to make different about an application, you should inject as environment variables. An example of that is, so if we go back into this application instance, we can see how the application actually gets the credentials of the database it's using. So if we echo VCAP services, so in Cloud Foundry you'll see VCAP a lot because originally it was called VCAP. I think it was a VMware Cloud Application Platform or something. And if you go on the mailing list is VCAP Dev. So yeah, so the application will get this environment variable, and it can pass JSON. If it can pass JSON, it can pull out the information. So I can see here I've got my Redis database, which is named Cloud Currency DB. And if you remember back to when we looked in the manifest, that name is actually coming from here. So it's bottle currency-db. So here it is. So I can pick this out. I can then see what the host name is I'm supposed to connect to, the port, the password, the name. Every binding of an application to a database or a service rather, generally the service will provision a new set of credentials. So if I have one backend database and I have 10 applications connected to that database, each application will have its own credentials to talk to them. And if your application doesn't actually want to pass JSON, because it wants to keep it a little bit simpler, we do provide some helpers. I think we've got a Redis. Oh yeah, so Redis URL. So that's another environment variable here. So if you're using a Postgres database, it would be Postgres URL or MySQL URL. So it's very easy to pick that out of the environment. And then I'm not that familiar with this application, so let's see if we can easily find it. So yeah, so you can see here it's picking Redis URL out of the environment, and then connecting to the Redis database. And that's basically all your application needs to do. So I could also run this application in a Docker container on my machine, and all I'd need to do is set up a Redis database running on my machine and then pass it in an environment variable. So that makes these cloud native applications very portable across any kind of infrastructure. And that's one of the important things about 12-factor applications. And if you don't know what 12-factor applications is, I recommend going to 12factor.net. And this is kind of a manifesto that Heroku have written. It's just 12 things that a cloud native application should do. And you go into each one, and it's just a couple of paragraphs that explains about it. So kind of versioning the code base, where you should store your config, how things get wired in. Port binding is another one. So I don't know exactly what that means, but generally in Stackato, like you can an application can either bind to a specific port, or it can pick a port out of the environment and bind to that, and that will get wired into the cluster. So everything it needs to bind in always goes through environment variables. And then logs that go out always go to standard error, standard out. Or in the case of Stackato, we can also have you write them to disk, and then we'll pick them out, and then we'll pump them into the system. Is there anything else I can discuss? I'll bring up my question slide.
Any other questions? No, I think we're good. Anyone else have questions or? Yeah. So the question was, what's the difference between choosing Stackato or some of the other Cloud Foundry services, or Heroku or anything like that?
Yeah. So I mean, it depends what you're looking for. I mean, we mainly target large enterprises. So a large enterprise can fire a big cluster of Stackato and run it on their own infrastructure or in the cloud, or potentially across the both of them. They can wire it into their LDAP directory, and then they can organize groups of users and different privileges. They can have fine-grained control on where applications are going and how they're scaled up and distributed. With Heroku is mainly targeted at startups, and it's public cloud. So if you've got a smaller application that you want to run just in the cloud, you don't have a large team or organizations, and you don't care too much about how it's distributed or routed, then Heroku is a good option. Well, I'm not really sure. I'm not that familiar with Heroku lately, so I shouldn't really say it's a good option or not. But and then, I mean, if we're talking about like different options of platform as a service, then obviously there's the open source Cloud Foundry, and with open source Cloud Foundry, there's a lot you've got to understand before you fire up a cluster. You've got to understand the deployment mechanism, which is BOSH. The minimum deployment is 27 VMs on Amazon, which is the default configuration. Obviously, we have competitors, but there aren't many. And then there's other Cloud Foundry-based public platforms and services. So IBM has their Bluemix, and there's a few out there. But I mean, we're very strongly focused on like large enterprises, but I do kind of feel that like anyone, even like a small startup, if you don't want the overhead of trying to figure out how to fire up bare bones VMs and then install system dependencies and harden the machine and install the database and wiring it all together, then maybe it's just easier to just fire up a small cluster of Stackato and push your code and be done with it. But that's, I mean, it's kind of a business choice. We're not very focused on small startups, so we give it like a small cluster away for free. Does that answer your question? Kind of rambling there.
Any other questions? Yeah. Did you hear the question?
Sorry, I was straining my ears, but I couldn't quite hear.
So the question was about build packs, and does Stackato, is it abstracted out? Does the app know about Stackato because of the build packs? Is that the question? Does it have to even know about Stackato, the app, because of the build packs?
That's a good question. So, yeah, there's always been some slight differences between Cloud Foundry and Stackato and Heroku. So a lot of build packs historically have been developed for Heroku, and then we originally introduced build packs to Stackato as an option, and then in Cloud Foundry version 2, everything became build packs, and so a lot of build packs come from Cloud Foundry, and they're taken from Heroku and tweaked to work on Cloud Foundry. And sometimes we need to tweak them a little bit to work on Stackato. Sometimes they work straight away. Sometimes Heroku one works straight away. But I think everything is kind of converging so that build packs will work anywhere. So yeah, I mean, if you're deploying an application to Stackato, then you'll often use the Stackato build packs. But I mean, there's lots of open source ones that work with Cloud Foundry as well, and they just work off the shelf. So it depends on the build pack, because sometimes the build packs build in specifics about the system, and sometimes they don't. But generally, when we have to tweak the build packs, it's like just changing a directory or something.
So I just remember the problem I had using Cloud Foundry. When it first came out, I tried to use it, and my application had a lot of user-generated data, a lot of uploaded files and images and stuff, and because you had to reload the whole app and everything, I would have had to have backed up all the user's data, updated the app, and then restored all the user's data. Is there a solution for that now?
Well, I mean, we have the file system service, but it's mainly targeted at like just I guess smaller files. It's not really a blob store. If you're looking for something like a blob store, then in development there is the Ryak CS service broker. So Ryak is a distributed database, but they also have a Ryak CS, which is a kind of blob store. So you can use that with Cloud Foundry now. I'm not sure whether it's ready for the prime time yet, but yeah, that's one option. You basically provision that, and then you can send files to it over the Ryak CS protocol, which I'm not too familiar with. I assume it's like get, put. Is that the kind of thing you're looking for, or you're looking for something that's just a file system?
Yeah, my app at the time was just writing stuff to the file system.
Yeah.
So I was saving the URL or the file location to the database and storing the file in the file system. So yeah, if I actually stored the files in the database, that would have been sort of okay, but I didn't really do that.
Yeah, so the services in Cloud Foundry don't have to be databases. They could be anything. So they could be somewhere that you just post a file, and then that file is just, that service is then serving them up. It's quite common to use like CDNs or something for files that you just want to serve up over the internet. That's another option. But the core of the application, to be a cloud native application, shouldn't store anything on disk itself, because that disk could go away anytime. So you can use the disk, but it should only use it in a temporary manner.
So, Phil, you have another question? Sure. Last question.
Okay.
Yeah, it has health check, right? That's monitoring the apps.
Yeah. So the health manager component is the thing that monitors the application. So it will. Well, there's two things that kind of monitor the applications. There's the DA, which knows if the container goes away. So if the application dies, the container will die. So that's one health check. And then the second one is a kind of polling of the HTTP endpoint that the application exposes. And so if the instance isn't responding on that endpoint, then it will terminate the instance. And when it does that, we'll bring up another instance to make sure that you've got the exact number of instances that you requested.
Okay. Hey, Phil, thank you so much. I think we got better questions today than we did on our webinar Friday.
Okay, that's good. I couldn't hear them. I think we were going back because they were getting quieter and quieter.
Yeah. Hey, thank you.
Okay, thank you.
I appreciate it. And if anyone has questions for Phil and you don't know how to reach him, just contact me, and I can certainly send them across to him so we can get them answered. And we appreciate you taking the time tonight to help us out.
Yeah, thanks for inviting me. Have a good night.
Night.